So I'm going to try to record a video that steps through the binary search algorithm. If I can figure out the video editing tools, I will take this pseudocode, which is from page 219 of your book, and I will try to illustrate where we are in the code as I do this. We are trying to do a binary search, which takes a list of numbers like this and starts pruning out values which are greater than or less than the thing that you're looking for. At every single step in a binary search, we rule out about half of the data. In order to represent the region of data that has not been ruled out, where we know our item isn't, we're going to be using a couple of pointers. So we have a value first. So if first is equal to 4, and that means we're only interested in the portion of the list from 4 on down. And we have another variable called last. So for instance, if last is equal to 8, that means that we're only interested in the portion of the list that goes up to and includes the value 8. So by changing first and last, we can indicate the sub part of the list we're interested in. If first and last are both equal, so in this case both first and last equal 5, then we ruled out everything prior to 5 and everything greater than 5, and that means we have a list with one element in it, in this case dog. Right? If somehow first is greater than last, then that means we would have ruled out everything prior to first and also everything greater than last, which would mean we ruled out the entire list. So if first is greater than last, then that means the list is empty and whatever we would be searching for can't possibly be in it because we ruled everything out. So with that kind of idea in mind, I'm going to trace through the Boolean binary search algorithm. Oh, they call it Boolean because instead of telling you the index, this algorithm just tells you true or false is the thing that you're looking for in the list. I think you can imagine how to add the index. Stepping through the code, the first thing we do is we set first to 0. And once that's due, we set the last to length minus 1. Length here is 11. We set found to false. And now we begin looping. While first is less than last, first is less than last, and we haven't found it yet, we're going to set middle equal to first plus last over 2. So first is 0, last is 10, and 10 divided by 2 is 5. So middle is 5. If the item equals data middle. So I should have said this before, but we are following along with page 220 of your book, and the thing that we're searching for is cat. So the item we're looking for is the word cat. So C comes before D. If the item equals the data in the middle, so cat does not equal dog, then we would return true. We don't do that. We're going to skip to the else block. Nested inside the else block, it's important that this is nested inside the else block, is a second selection statement. If item is less than data middle, so is cat come before dog in alphabetical order? It does. Then we're going to set last to middle minus 1. Okay? We can rule out middle because we know cat did not equal dog. So we set last to middle minus 1, which means we ruled out everything below deer in this list. That cut off a lot of the work. Okay? We can skip the else block and repeat the loop. So we go back up to the top of our loop, which is this while statement, and it says while first is less than or equal to last. First is still less than or equal to last, and not found, we haven't found it yet. We set middle to first plus last over 2. So 4 divided by 2 is 2. item equals data middle, does cat equal chicken? No, it doesn't. Then we said found it true, it doesn't. So else, if item is less than data middle, is cat less than chicken? It is. Then we're going to set last to middle minus 1. And we flipped it upside down. That ruins my entire plan. My fat fingers. Okay. There we go. So last is set to middle minus 1. And that we go out of that selection statement and we go back up to the loop. Is first less than last? It is. And have we found it? No. So what we do is we take middle and we set it equal to first plus last divided by 2. So last is 1, so middle should be 1/2. But we don't have a good way to represent 1/2 on our computer. So what we always do is we kind of truncate down. So we take 4. What is the largest number less than 1/2? And that's 0. Right? So if you have a number that's between 0 and 1, you do 0. Whenever you have a number between A and B, you choose the small one. Okay. So middle is 0. If item equals data middle, does cat equal ant? It does not. So we skip that. Else, if item is less than data middle, is cat less than ant? Does cat come before ant in alphabetical order? It does not. So we skip that and we go to the else block. We set first to middle plus 1. So middle stays at 0 and first becomes middle plus 1. Right? So now first equals last equals 1. And we repeat the loop. Is first less than or equal to last? That is true because first equals last. Have we found it? We found it's not been set to true yet. So what we do, we set middle to first plus last over 2, which means that all 3 of these things have the same value now. They're all equal to 1. And if the item equals data middle, does cat equal cat? It does. Then what we do is we set found to true. We found it. And then we skip the else statement and we go back up to the test at the top of the while loop. While first is less than last. Yes, first is less than or equal to last still. And not found. Found is true. So not found is